9.4, the tangent ratio. The tangent ratio involves the opposite and adjacent sides of a triangle from a given acute angle. Essential question, can you use the tangent ratio to find unknown sides in a right triangle? Let's take a look at these three similar triangles. They're all similar by angle-angle similarity, 37 degrees and 90 degrees. What we're going to do is we're going to take a look at the ratio of the opposite leg to the adjacent leg, and that's going to be 6/8. Opposite leg over adjacent leg, and that's 3/4. Opposite leg over adjacent leg, and that's going to be 9/12. Now they all reduce to 3/4, and that's what happens with all similar triangles of angle 37 degrees. They have the same tangent ratio, and this is going to help us find lengths of sides. Okay, and here's the definition, a tangent ratio. So the tangent of A is equal to the leg opposite angle A over the leg adjacent to angle A. And a lot of times we just abbreviate that and say the tangent of A is equal to the opposite over the adjacent. And it's understood we're talking about legs because we call this the hypotenuse. Okay, let's go ahead and I'm going to demonstrate how to find the tangent of S. So the tangent of S is equal to, now here's S right here, and the opposite is 80, and the adjacent right here is going to be 18. That is the fraction answer. It would be nice if we reduced it, so it would be 40/9, and then I'm going to round it to 4 decimal places. So I'm going to put it in my calculator, 40 divided by 9, and I'm going to put an approximate because I'm about to round 4.4444. Now I'm going to change my color and I'm going to find the tangent of R. Now here's R right here, and the opposite leg is 18, and the adjacent leg right here is 80. I'm going to reduce 9/40, and I'm going to put this in my calculator, and I'm going to get equal, there's no rounding here, 0.225, and since it said 4 decimal places, I'll just put a 0 to get that 4th place in there. Okay, now it's your turn. Go ahead and see if you can write the tangent of J and the tangent of K as a fraction and round it to 4 decimal places. And here are the answers. Okay, we're going to actually find a side using this tangent ratio. And so here's my angle right here. I'm going to write out the formula. The tangent of an angle A is equal to the opposite leg divided by the adjacent leg. In this particular case, my angle is 32 degrees. My opposite leg is 11, and my adjacent leg is x. And if I put a 1 under here, I actually have a proportion here. Now, the tangent of 32 for all right triangles with an angle of 32 have the same ratio. And we can find that in this little table here. So just read the tangent column and it'll be this. So I know that this can be replaced with a decimal. 0.6249/1 is equal to 11/x. I'm going to cross multiply. 0.6249x is equal to 11. I'm going to divide both sides by that decimal, and then I'm going to use my calculator and round to the 10th place. So I'm going to put approximate because I'm about to round. And the answer is 17.6. I'm going to see if this seems reasonable. So I'm going to write 17.6. Now remember, this angle is 58 degrees. And this seems reasonable to me because the side opposite a bigger angle should have a larger length than the side opposite a smaller angle. Now, what's nice is tomorrow in class, we're going to learn how to find this number with our calculator. So make sure you bring your scientific calculator. All right, we're going to use a special right triangle to find the tangent of a 60-degree angle. Now remember, a 30, 60, 90 triangle has this ratio x root 3, 2x. If we simplify it, it would be 1 root 3, 2 is my ratio. So I'm going to write a 30, 60, 90 triangle with these numbers, and then I'm going to double them. I'm going to show you what's going to happen. We want to find the tangent of 60, and we're going to look at the opposite leg, which is root 3, divided by the adjacent leg, which is 1. And when we simplify that, that's root 3. The tangent of 60 degrees for this other triangle right here, the opposite is 2 root 3, and then this is 2, and that simplifies to root 3. So this, I'm trying to show you that all tangents of 60 will give us the same number because all these triangles are similar, and so the ratio of opposite over adjacent will always be the same. All right, I'm going to set up number 3, and you're going to be doing number 4. So I'm trying to find this angle, I'm trying to find this side, but I'm going to use the tangent ratio. I'm going to write the tangent ratio again. The tangent of an angle is equal to the opposite leg over the adjacent leg. Okay, in this particular problem, it'll be the tangent of 61 is equal to 22 all over x, opposite over adjacent. I am going to use the table to look up what that ratio is, and this is going to be 1.8040 is equal to 22 over x. Now I'm going to cross multiply, and when I cross multiply, I'm going to get 1.8040x is equal to 22. Use my algebra skills to solve for x, and then I have to go to the calculator, and I'm going to be rounding to the tenths place. So this is 22 divided by 1.804, and I get about 12.2. All right, again, tomorrow we're going to be able to, most of us are going to be able to do this. We're going to set up the proportion, and then we're going to let the calculator do the rest of our work. All right, go ahead and stop the screencast and try number 4 on your own. And here's the answer. Okay, let's take a look at this problem. This is a problem that's helping us find the height, and this is different than our similarity experiment that we did. So I can see that this is a tangent ratio, so I'm going to write the tangent of 59 is equal to the opposite, which is h, over the adjacent, which is 45. I can put a 1 under here to make it look like a proportion. I'm looking at 59, and I'm looking at the tangent column. Now, pretty soon we'll talk about sine and cosine, but right now we'll just deal with tangent. So the decimal is 1.6643 all over 1 is equal to h over 45. So you can see we're going to cross multiply to get our h. 45 times, and when I get that answer, I'm going to get 74. Rounding to the tenths place is going to give me a 9. So this is going to be 74.9. Now, does this seem reasonable? Well, this answer is, this angle is 31 degrees. Opposite 31 is 45, but opposite the 59-degree angle should be larger. So this looks like I'm in the right ballpark here. Okay, it's your turn to estimate the height of the lamppost. Take a minute to stop the screencast and see what you can do. And here's the answer. And again, tomorrow we're going to actually learn how to use our calculator. So again, most students are able to, after they set up the problem, they're able to get to the answer using their calculator.